All right, hi guys. So first, I'm sorry that I'm out today. I had a kid at home who was sick, so I'm not going to be able to be in there today. So I wanted to leave these video notes for you guys to take and follow along with, and then get some practice in today. Okay. So we learned all about these exponent properties. Well, now what do we do with them? All right. Well, what we do is we're going to start solving some equations. Okay. So going old school here. When we're solving an equation, the first question is, well, how do you know what to do? Okay. You've been drilled all in your lives that order of operations PEMDAS. Well, technically, we're going to work backwards. It's really sad map. Okay. And well, if I give you this example problem number one, x plus 5, you read it out loud and simply you do the opposite. So minus 5, and that's where I get x to the 15. This one, well, there's no operation written between 4 and x, so that means 4 times x. Well, what's opposite of times? Divide, divide. Now, I technically use the word opposite. However, what you're using is called inverse operations. It's the operation that undoes the other one. So plus and minus, divide and time. Okay, so Stackhouse, where are we going with this? Why all of a sudden are we talking back basics like this? Okay. Because the same thing for inverse operations is applicable to our current stuff. So these ones have exponents, and this one has a square root symbol, but we know we could rewrite that as an exponent. Okay, so I'm just going to follow that order of operations that I talked about, SADMEP, because it's PEMDAS backwards. I'll subtract the 3 to both sides. So x squared is equal to 25. Done. Nope, just kidding. Haha. Right? The idea is x has to be by itself, and we can't have it with an exponent of 2. All right. So our final answer has to be x equals something. Well, secretly, it's x to the first. You just don't ever write that. Okay. So how do I undo, or what's the opposite, or what's the inverse operation of squared? Ready? So plus and minus times divide, square, square root. So I'm going to physically draw that square root symbol because, ready? That square root symbol and that squared, they cancel each other out. Because what I'm really doing is x squared, and the root part is the same as raising it to the 1/2, and 2 times a half, like our exponent properties, gives us x to the 1 because the 2's cancel out. Okay, so x to the 1, and now the square root of 25. When you are doing these problems and you physically have to draw the square root symbol to solve it, that's when we're going to have two answers, plus or minus 5. Okay. All right. So now let's move on this one. There's nothing out front and there's nothing out back that I got to add, subtract, or multiply to get rid of. So I have to now get rid of that square root. Well, what's the opposite or the inverse operation of square root? Squaring, squaring. Now that root and the squared go away. So x plus 3 is equal to 2 squared, gives me 4. And now I'm just going to solve it just like a basic problem. Okay, so that's how you do these kinds of problems. You take a look, right? Is you have to get the thing that's being squared by itself, and if it is by itself, then do the operation. Okay, all right. Let me scroll down just a little bit more. So, first question is how do you know what to do? Second is how do you know when you're done? You know when you're done when x is completely alone and x has an exponent of 1. Okay. Now, if I undo this squaring by square root, I'm drawing the symbol, so it's going to have two answers, plus or minus 2. Now look, x is by itself, and it has a sneaky exponent of 1, so I'm done. I get rid of square root by squaring. Those go away, so x equals, now this is going to be a big number, 196. Right, 16 squared is 256. Nice try, Stackhouse. Jeez, it's 5:33 in the morning for me too. So 256. Okay, but x is by itself, and the square and the exponent is 1. So I have both those things. I am done my problems. Okay, gotta finish these notes up. Almost done. So I have a couple examples for you to try on these. And Miss Tuttle has the answer key, so just check those out. All right. Third question is okay, do we have any extra answers? This fancy math word is extraneous. Means I can solve a problem, but technically I don't have the answer. So, like for example, this problem right here. There is nothing stopping me to solve this equation. So I square each side. X equals, well, -6 times -6 is positive 36. Great. But if I plug that back in and I check my answer, square root of 36, and I plug it in, I don't get -6. I'd get plus or minus 6. So technically, this answer of 36 does not work because it's extraneous. It's an answer that kind of works but doesn't overall, so we get rid of it. Okay. All right. So extraneous answers, right? And then the last bit for today is whenever you have a square root equal to a negative number, you can't do that problem because it's going to be no real solution. Here's why. Okay, we haven't talked about this, but if I give you a graph, my red curve is going to be the square root symbol. So this is the picture of what square root looks like. And if I pick any number down below, which is negative, when does that red curve ever touch anything down here? Answer is it doesn't. So that's why it's no real solution. So you can't take a square root of a negative number. All right. Thanks for watching, guys. Check those answers for the 4 examples with Miss Tuttle. And if you have questions, you can always email me. All right. Thanks, guys.